Okay, for people joining this live stream, we are going to be talking about the question of how one represents formal theories in Wolfram language. So, for people, let's see, do we have, actually, is Andre here yet?
He's not, but he's on his way.
Okay, oh boy, maybe I'm going to have to give the introduction twice, but okay, so it goes. All right, so the issue is, what's a good example here? Ring, for example. Okay, so in axiomatic theory, we have...
Oh, Andre just arrived.
Okay, great. Okay, so we're talking about representation of formal operators in Wolfram language. Okay, so normally when we have, a plus or an F or whatever else, we sort of know what it means. But we have this notion of formal operators that we use for theorem proving and so on, where we don't want to say what that plus is. We're representing it as circle plus here, but we just want it to be a formal plus, just like the A's. The A here is a formal A, and we invented this mechanism a few years ago of these dotted formal characters, right? Which represent, which are set up. I don't think you can assign values to them. I think that's, that. Why am I getting this thing going to, how do I set this not to go to the messages window? I don't know how it set itself to go to the messages window. How do I unset that? John is the expert.
Yeah,
It's probably in the preferences.
I think it is. Yeah,
but I think it's also a bug that it caused me to have, that it went.
This has happened on your system. There's been a history
multiple
of this
times.
for
I know.
a long time, and we've never figured out.
Well, unless it has to do with some of the apps that we, have.
I'm sure it does, but still, it would be good to know, like, which one's doing it, and we haven't even figured that out.
Right, and I'm sure that it's happened in the last day to me right now. I mean, in fact, probably, can I bring back the messages window, or to just close it and it's now dead? And whatever.
You can get it back from the window menu.
Window menu.
Right, but is it still going to have its content in it, or is it going to be?
Yes, it will.
Okay, then I think I can tell you. Oh, look at this! Look at this! Look at this! I wonder whether this has to do with the parallel kernel stuff.
So, Stephen, to fix it, option inspector.
Okay, I'm just going to give you a. I'm going to make for QA. I'm going to make a copy of this
Okay.
messages window. I have a suspicion actually that it had to do with a presentation I did yesterday, and I was given a notebook for it. Let me just send that out. Is there somebody PMing? Brady is PMing here. I'm going to send this to you.
Okay.
Okay. Sorry. Tell me what to do. And then
Option inspector.
Option inspector. Okay.
Okay. Global. You're looking for message options. You can just type it in. Those first four: warning, error, console, kernel. Just click the X's next to them all on the left. Click the X's to make them go away.
The warning one isn't just a beep.
If you click the X's, it just sets it to default. Which actually, I guess I mean,
Why does that say print to console? Kernel message action says print to console.
Ooh, it certainly shouldn't. That
that default went bad.
Yes, and I suspect that somebody's modified something to change the apparent defaults. I mean, you can do that by.
All right. Well, so that may be the problem. Okay, so let's record that fact and let's go on with our meeting.
Okay.
Wouldn't it be set at the notebook level? You could have looked at it at that scope, right?
But we want to change the behavior so it's fixed for all of his notebooks.
Okay. You know what? This is still doing this. This is still doing it. It just didn't send the message to the right place. It just did the exact same thing.
So check that preference at the notebook scope. Let's just see what's going on. Or for the front end,
It
we
can't
might
be
have
set
to.
at the notebook scope. It's a
Okay,
global-
so
Yeah,
what
no,
about
this is-
front
this
end?
is-
So it's
That's
either
global.
Well, but that's what global is.
Print to notebook. It says right there, kernel message action, print to notebook.
It removed the beep. Sorry. Make it just print to notebook. I think that's a bug in the front end, which we've just never gotten around to fixing.
Nope, still happens. It's
Yeah, but-
beeping. It's kernel message action. This is a kernel message, right?
Yeah. Yeah. I wonder if somebody, I mean, I don't want to spend a lot of time debugging this, but I can imagine possibilities of ways that it might have been, torqued by something, but I don't want to spend a lot of time on this right now.
Right. Fine. But if somebody can work with Roger and
Yes, we can do
So
that.
in my front end, there's no list around it. It's just the string.
But that shouldn't make a difference. The beep thing, I remember a bug about that, but that should not make a difference.
Nope.
No, it doesn't make a difference. It did the same thing.
Yeah. So
Did somebody modify it at $front end session level? Is that
that's a possibility, but I feel like we spent enough time on this already.
okay?
Well, should I just restart the front end?
I doubt that it will make a difference.
Okay. I really need I mean, this bug needs to get fixed, but okay, no matter. Let's just go back to the meeting. Let's see. Okay, onward. So, all right, so introduction to this. The goal is to represent an expression like this formally, okay? The variables are even more formal than our usual symbolic variables. They're not supposed to have values. They just stand for, they kind of stand for something which can stand for something. Now, these operators, we chose in building axiomatic theory to just put in these operators as, it's really a plus-like thing, but it's not necessarily plus. You understand what I'm saying? The people, okay? And the problem is that we have a proliferation of these things. Some of them are unary operators. Some of them are things like that's an identity object, which is kind of an object-like thing like this and so on. And the problem is we got a whole proliferation of these things. And the question is, what are we going to do with them? And one possible idea, which I want to float, is the possibility of having a formal operator that is like a dotted version of plus, where we just go plus, but it is, I don't know if I can even do this on my, what is it? It would be, how do
you want control 7 or control comma? Are you going above or below?
I want to go below.
Then that's control comma. I think.
No, it's
we removed
shift control
it,
comma.
Shift control comma. Yeah, that thing which you claim that nobody ever uses, besides the fact that I use it all the time. I will just point out that you just wanted it.
I know. Your point is made.
But shift control comma isn't working. It's a little disturbing.
Let's see, below. That's what I want.
Oh, control 4. You have an older front end apparently.
Okay. All right. Okay. So then my question, and that doesn't look right at all, but my question would be, one possible approach would be to just say anything can be dotted and keeps the same precedence. You see what I'm saying? That's one possibility. The other possibility is that we introduce a whole bunch of new glyphs, basically, to represent all of these, that we take, I'm a little worried because we may end up, and this is a question for the axiomatic theory people, Jonathan, Mano, others, I don't know whether we're going to end up with two different plus-like operators that we want to represent. Is this making sense to people? So
it could definitely happen.
Well, and the problem is that what we really want to do, it's very convenient what we have right now here with Circle Plus and so on, because, if you're trying to type an expression that involves Circle Plus, it's very straightforward to do that, et cetera, et cetera, et cetera. We have all the support for it. The problem is we need a boatload of operators, and many of them don't have the right precedence. See what I'm saying? And that's the problem. I mean, we can introduce new formal operators and content folk like Jonathan. Can we, or Mano, do we have sort of an enumeration of what kinds of formal operators we think we need?
Not really, because I mean, what we're going to be putting into axiomatic theory is kind of unbounded right now, right? I mean, so far everything that's in there is equational. Hopefully soon we're going to have first order logic, and then hopefully soon after that we're going to have higher order logics.
But they don't have operators mostly.
Is that true?
I don't know. Actually, I don't really know, but I don't think so. I mean, I think most of the infix operator stuff is equational. Look, so for example, what we've been doing is we've been using V as our sort of faux OR. I mean, whereas if we say OR AB, at least where we have A and then we have / bracket OR, and that looks kind of the same, but V doesn't evaluate and OR does. But I have no idea whether they even have the same precedence. Anybody even know?
I think they do, but I would have to double check that.
Well, let's just intermix them and we'll find out something at least.
Unformatted, that's sort of the easiest way to tell. So
boxes left.
Yeah, so I think this is telling us that V has higher precedence.
Where is the precedence table?
Tutorial / operator input forms.
Tutorial singular / operator input forms.
Yes.
Oh, for goodness sake. A beep. A beep. A beep to a mysterious off-screen place. Okay. Operator input forms. Here we go. Okay, there's wedge. I have no idea where V is. So the issue here, I mean, again, we've got a certain number of meaningless operators that we've included in here. And, the challenge is either to just introduce more of them, including prefix ones. Could whoever's typing mute themselves? Or take a different approach. So thoughts from people on this. Okay, Jonathan, picking on you, okay? What do we think the future? I mean, so we've also got even the equality sign. We really need a non-meaningful equality sign, don't we?
Yes, exactly. And that, that's a problem we're running into in these first order theories, because almost by definition, the equality predicate is not equational. It's not a predicate of equational logic. It's a predicate of first order logic that then defines equational logic. And then
yeah,
a bunch of these, right? I mean, so things like even subset relations in set theory or morphism relations in category theory, right? These are all first order or higher order kinds of predicates. They're not equational, but we still, there are things like, with subset, for instance, obviously there are Wolfram language symbols for that, but we want to have formal versions of those, which right now we can handle by putting them in hold, but it would be better if we had a formal variant.
Well, okay, so that's another possibility, that every one of these could be done with inactive operators.
Right.
Whoever's making a background noise, that really could, I mean, there's just a whooshing noise. It'd be great if you were on mute. I'm suspicious of John here for some reason.
I'm not hearing anything, so maybe I'm to blame, but
then that would be a guess. Okay. In any case. Okay, so look, one possibility is an active op. Okay, so let's list our possibilities, okay? So one possibility is inactivated operators, inactivated ordinary ordinary heads. Okay. Another possibility.
And many of those will work. I mean, some will format unexpectedly, but I'm pretty sure that inactive of equal will look just like you know, right? It'll have the gray styling of inactive, but
Oops.
You need that to be inactivate,
right?
And probably, you know, add an equal sign or something.
So one fundamental problem with inactive, and is the reason why I didn't want to use it in axiomatic theory, is because of flatness. Inactive preserves flatness, which in theorem proving we don't want. So okay, this is a fundamental issue that we keep running into with these kinds of things, and it's whatever our solution to this is. I think it definitely should solve at least this problem. So when you do equational theorem proving and you define a predicate, that predicate had better have fixed arity, right? If you define an AND operator, it needs to have fixed arity. The fact that AND has a flat attribute in the Wolfram language therefore causes huge problems, even if you inactivate it.
Right. Well, yes. So this doesn't sound like something that can be solved by dotting it, because I don't know how. I mean, besides even other implementational concerns I have of that, it's like how it can't guess what the new arity is.
Right. Okay. So fine. So constraints, right? So that's an important point. Arity is defined.
It doesn't need to get, right? Because I mean, like with circle plus, it doesn't assume any arity, does it?
Well, let's find out how horrifying it is. Let's find out whether circle plus ABC, I think that'll format like that. But now circle plus of
AB, of A circle plus BC doesn't do that, because it doesn't assume associativity. It can't.
Right.
So we can do it with formal symbols, but with
but neither does AND then. If this is your concern, right? If you do hold or inactive of AND, right? If you inactivate a nested AND, it should be properly nested.
That's fair enough. Yeah. Okay.
Okay. So what was the thing that Jonathan was concerned about then?
Maybe this isn't a problem.
Okay.
Maybe inactive is fine.
Well, so arity is defined / fixed. Okay, so inactivated or ordinary heads. The other would be dotted operators. Another would be new formal operators. Now, I mean, we have to, okay, arity is defined, but what we got to be dealing with is both binary operators, binary plus operators. We've got probably prefix operators.
But sorry, just to quickly finish the other point. I think the thing that concerned me the last time we looked at this was that if you do something like inactivate, A ampersand ampersand B ampersand ampersand C, it assumes that the AND
no. It doesn't assume anything. You typed in a flat AND.
Right.
If you type
so inactivate can't work.
Inactivate can't, but inactive can, I think is the moral.
No, if you type in what you mean, inactivate will do it. Right? Do hold complete of, A ampersand ampersand B ampersand ampersand C. That parses to a flat 3-argument AND. Right?
But that worked. What I just did worked.
Right, because you actually typed in a nested AND, and then because inactivate is hold first, hold all, whichever it is, it saw it, and it didn't have a chance to flatten itself via evaluation, and therefore it inactivated what you wanted.
Fair enough.
All right, now what happens if I do traditional form of this? That's terrible. Why isn't that showing the nice wedge for the and?
Because we have no data on which things, have alternate, right? We don't have, right? When we have like 5 different operators for the same head, it picks one, and in this case, it picked that. I mean, we could put in a special hack.
No, but Atai, look.
Yes, and that's because there is a special make boxes rule for and that.
Okay, but this is an implementation. I mean, this is not a point of principle. This is a point of implementation, correct? I mean, we don't. There's no reason why we think that this shouldn't work. I mean, in other words, the traditional form for plus isn't plus; it's a plus sign. See what I'm saying? I mean, there's no good reason why this can't work. Is that correct?
Right. Other than somebody would have to put in a hack one operator at a time to get what you want. Yes.
Well, I don't know what's a hack. I mean, it's just a question of what the formatting of inactivated operators is.
No, I mean, there's a default rule for inactivated operators, and that is what the default rule does. And if you want to add in a special rule for,
but I'm sorry, the default. Why isn't the default rule saying go look at the traditional form that this would have if you were not inactivated?
Because I don't think it can do that.
Why?
Because because we don't have a table of that anywhere.
Okay. Well, fine. So we have to create one. Okay, fine. But let's just. I mean, this is its own separate little baguette here, which should be fixed. But that's separate from our main question of whether that's even a good idea. I mean, this is kind of a killer in terms of making things look reasonable. Look, could whoever's not on mute possibly put themselves on mute? Thanks. Let's see. Again, the question that we have is, in setting up these formal axiom systems, is it obvious that there is a corresponding ordinary operator that goes with every operator we're bringing in here? Probably not. Right? I mean, something, like group multiplication, it's kind of like a multiply, but do we really want to consider it actually a multiply? Actually a times, so to speak? Am I making sense?
Yeah, probably not.
I mean, an activate of x times y times z, oh, it does have times signs in it. Well, that's nice of it.
Right, because Lou went in and added a special rule for times.
Is Lou here? Maybe he could comment. Did I see?
I am here, and as I recall, Itai did this.
I did this? Okay. Well, I guess
Lou, does it seem obvious to you how to fix this case?
In traditional form?
Yes.
Yeah.
I mean,
as Itai says, we just add a rule.
I mean, we can do a one-off for and, but there.
No. Why aren't we doing it for everything? Everything in traditional.
Because how do you think that can happen?
Well, to do that, we would have to provisionally typeset it without the inactive, and then see what it turns into, and then somehow retrofit.
Right. And not every operator will use. Not even every binary operator will use a row box of 3 things with some operator in the middle.
Well, I mean, I'm sure we can machine generate the code, right? Because we can just run it with formal variables and see what it does and extract what it does and put that into a box. And that is the rule. It's a weird way to do it, but that's what we could do.
I don't know what you're suggesting there.
Well, I mean, the other possibility is wherever the traditional form code is, there's just a version of it that basically would be inserted in the inactive case.
No, that's not how make boxes roll. That's not how make boxes works.
Okay. Well, then what I'm suggesting is you take something like traditional form of, take formal A times B here, and B, okay? and you simply look at what is the what is it, 2 boxes of the traditional form of A times B given that operator, and you've got the answer there. And so what you do is you simply go through, and for every operator in this table, you simply ask what is the, since you know it's binary, ternary, n-ary, whatever it is, you simply go through and you ask what is the corresponding boxes form, and that becomes a rule.
So you mean hand generate something for every single thing?
Well, it's not hand, I mean, it's machine generate, but yes.
What do you mean machine generate?
I think what Stephen means is that you machine generate not when the user does it, but we machine generate the rules, which we then,
yes,
include with the product.
Right, that's what I mean. And some of them will have to be edited in some careful way because of the way that inactive works. Okay, but anyway, let's put that aside. That's a thing that should happen, but that's a different issue. That's not solving the problem, because what we need here is formal operators that aren't exactly plus and times, right? And what we've done right now is we put them, with circle plus and so on. And what I think we should do is introduce a certain number of formal operators that we call formal this, that, and the other. What am I saying? With that we can then use. Now we have to choose, and this is a question, when we chose the operator precedences here, years ago, 25 years ago, whenever it was, more than that now, I carefully looked through many, math books and so on, and I found, to my great surprise, a huge degree of consistency in the effective precedence that was being used. Am I making sense? It's not obvious that the relative precedence of for all and T operations and implies and so on would be consistent, but it was. Okay, and that's what and there really wasn't a lot of ambiguity. I mean, it was really very slam dunk, and that's what led to this precedence table. Okay. But so now the question is, can we introduce a new collection of, I don't know, 20, 30, formal operators whose precedences are fairly uncontroversial that can be used to form these formal, axiomatic theory setups? Does that question make sense to people?
Sounds good to me.
Right. I mean, if we're just talking about adding a fixed number of operators with, in the standard manner, then I see no problem with doing that.
Right.
Okay, other than, I guess Andre will need to chase after. Well, I guess if we're okay with programmatically adding the dot to the existing glyph, then
no, we're not, because I don't think that works. Because we can end up with 2 formal plus operators, right? You understand what I'm saying? So that's not going to work, right? So we're going to have to come up with what we...
By which you mean a prefix version and an infix version?
No, worse than that. You think of arithmetic, okay, look at this case. This is the axioms of ring theory, okay? Ring theory, one of the models of ring theory is traditional arithmetic with plus and times. I'm not educated enough to know, maybe Jonathan could tell us what the other models of ring theory are. I'm sure there are other models.
There are dozens, right? I mean,
yes. Okay, there are many rings. Yes, obviously, right. Okay, I'm being silly here. But anyway, but the ordinary plus that where we say PLUS 78, okay, isn't that plus. There's a formal plus of which that is just one model. And the thing which is awkward is there could be an axiomatic system where there are 2 things that behave a bit like plus, but aren't really plus, if you understand what I'm saying. John, did that make sense? Right?
Yeah.
And that's why, but this is where we have to, what we did in version 3 was we guessed, we introduced all of these operators without built-in meanings, which frankly have not been much used over the years. We've got all these lovely operators like, the union, this thing here and so on, but people don't use them. Now, finally, we actually have a use for them. And in axiomatic theory, we have been making use of things like circle plus and circle times, and they've been very helpful. So, it could be that the right solution here, which involves a subset of the people here, is that we simply go to the idea that we will have essentially formal operators with certain names that are just glyphs, and they just act accordingly. Okay? And they are an extension of our operators without built-in values type stuff. Does that make sense? I mean, that's what we're doing. The problem is that, for example, we don't have an adequate collection of prefix operators. The only one that is really common is the square. And, I've used that a lot, but it's just like a really weird thing that
yeah, we don't have a lot of prefix operators, period. But right. But yes, the ones without built-in meaning are even more rare.
Right. Well, now we also have what we might call overfix operators, and I don't know whether those are important. I mean, I've certainly used those in, I've used this in the axiomatic theory stuff. In fact, I think we use that for knots, don't we? Do we use that in Boolean algebra?
Yes.
Okay, so that's kind of a hack, because it's a unary operator that sort of looks like a negation, and so we're using it for that. It's a unary operator without built-in meaning.
There's the corner case that you can see in the ring axioms stuff. So one of the design decisions we made with axiomatic theory was to treat constants as effectively operators of arity 0.
Yes.
Right. So like, you can see the additive and multiplicative constants there are treated as just, those are treated as operators, and presumably those would be formalized. And we use, in that case, we use over tildes to make them into, to distinguish them from actual zeros and ones.
Yeah. Now, for example, Nick on the live stream is commenting that the function he wrote, find head arities, well, that got all tangled up with inactive symbols. It will similarly get tangled up with these kinds of things.
Yeah,
the non-symbol nature of that. What's that?
Find equational proof gets tangled up with inactive symbols as well. They're a bit of a nightmare.
Well, okay, so with these nullary operators, or what do we call them? They're not unary operators. They're zeroary operators. What is a zeroary operator called? I don't know. But anyway, there is the possibility that we could just introduce new symbols to represent those zeroary operators. A formal, so that would be something like formal 1, formal 0.
Right.
Which would then just be, symbols like this, and those, to be consistent, could potentially be. I mean, I'm not sure this is the right strategy, but they could be dotted versions or something of normal things. So, I mean, this is the question really, is can we consistently invent, okay, so what we're coming down to here is that what we need are just a bunch of new glyphs. Is that?
Okay, I mean, did I hear correctly that just putting a dot alone isn't going to be enough because you need variances? And so these are,
I think so,
more than just dotted things. They'll have some other.
Well, I mean, I'm hearing that maybe a dot would be sufficient in some cases, but not in every case.
Well, it's also, we need a style.
Well, I get, just to be clear, you're not suggesting that we have more than one formal plus just because there are more models of plus than one.
No, I'm saying that there are theories in which there are two plus-like operators, I think.
Well, okay, let me give a trivial example. If we wanted to axiomatize module theory, for instance, or the axioms of vector spaces, you have the plus over the field of scalars, and you have the plus of the vectors, and those are different operations.
Right.
The field, the ring of scalars, or whatever.
So the question, go ahead. I mean, the way I see it is ultimately, okay, so if does somebody have an example? Maybe we can pull up an example from find equational proof of one of those, syllogism type things, because that's an axiomatization where all bets are off in terms of using infix operators and so on.
You mean a first order syllogism?
Yes, for example, is that in here?
Yeah, there's one of the Socrates one at the bottom there.
Here, okay. So this, we're not going to have mortality is not is never going to be an infix operator. We're not going to want that with infix operators.
No, but well, I mean, okay. For instance, might we want things like betweenness in Euclidean geometry?
Yes, we might. So let me give an example then of where we're going with this. Let me show you an example where I wrote out axiomatization of all the axiom systems that I sort of knew at the time.
Right. Like your typical interpretations section of that, where it is, page 774, has, basically, I think most of the operators that we would want to include.
Oh my gosh, Brady, did this actually expand correctly? Well
yeah,
done.
That's been live. Yay.
Well done. Good work. Great
Thanks.
example of use case. This was a great use case for that.
Right.
Okay,
so
here we go.
Right. But can I get back to the plus thing?
Mm-hmm.
So, right. So I agree that to axiomatize vector spaces or modules, you need the field or ring plus, and you need the vector or module plus, which typically when you're doing that, then you'll use plus for the field and circle plus for the vector space or some such.
Exactly. Obviously, there are generalized cases where we, the more variant, in my view, the more variants we have, the better.
But I mean, so this is a typical thing in, mathematical logic, in the end, I mean, okay, the good news is in the end, we can go to things like this. In the end, we can just go to random symbols. But to make these axiom systems look nice, we might as well have as much diversity as we can, it seems to me. Knowing that there's a fallback. Mm-hmm. And the fallback is not going to tangle up any theorem prover. It's not going to tangle up anything because it is, in fact, the same structural arity type form that the original was supposed to be. It's just it doesn't have an infix format. Does that make sense to people? So, I mean, things like empty set, we probably want a formal empty set. That might be different from some future, empty set that is, I mean, I'm surprised we've never needed an empty set symbol.
Oh, we have an empty set character.
We certainly do, but I don't think it means anything.
I
don't think that the empty set, I don't think if I say...
I think it's a letter-like form. Yeah, it's a letter-like form, so it creates a symbol in the current context.
Right, which could in fact be the empty set symbol if we wanted it to be. If since we don't have a notion of sets really, we don't, we haven't needed that. Ethan is giving us a list of symbols that could be added. Let's take a look here. Oh boy, this is, I mean, look, ultimately we can add any Unicode character, and I think we can have, I mean, that's another question. Okay, so next question is, can we preempt Unicode? Can we give a formal meaning, i.e. parsing, for a random Unicode character?
No.
You're saying we shouldn't?
I'm saying we shouldn't.
So you think anything that we put in here should be in private Unicode space?
Well, or
it should correspond to the if this same if that operation exists as a character in Unicode, then we could reuse that.
Yeah, I mean there may be ranges of Unicode glyphs that have are intended to have the kind of semantic meaning we want to ascribe to it, and in which case it'd be fine.
Okay, well, so let's assess that. I mean, maybe Unicode already has some nice section for mathematical logic where it already has all these things.
It has several sections on mathematical notation. I think
no, mathematical logic, I said, because this is where this is going to come up.
Well, yes, but mathematical notation is broadly defined. So, I mean, there are sections which are literally called mathematical operators or mathematical notations.
I know. So Ethan sent us this thing on the live stream. So let's just look at
well, that's tech.
I'm aware, but I'm asking whether it even has a section for logic. Okay. Oh my gosh, it's got Frege's Begriffenschriften symbols in it. Wow. I'm impressed. That is definitely on the obscure end of things. Did Don Knuth really talk about those anywhere in his books?
Note that that's not in LaTeX itself. That's a package. That's a package called Frege.
Oh, I see. Okay, I mean
Not even Knuth is obscure enough to have the Begriffsschrift supported by default.
Right. But so let's take a look at Unicode then. Okay, so this really doesn't have a lot of other logic. Maybe it does. I don't know. Nothing obvious.
Unicode list now. I mean, it has at least some logic symbols. You know, you have the implications. You have if and only if. What else do you have?
How do we find a Unicode character?
I'm looking at a Wikipedia page called Mathematical Operators and Symbols in Unicode.
Adopt a character? I didn't know they had that.
I'm anxiously poised to receive your command to add Homer Simpson to our characters.
What is this? This is really weird. That is bizarre. Huh, I had no idea this was possible. That's interesting and strange. That is a new thing. That's something I'm surprised is okay.
I put a link in chat that may or may not be relevant. It's slightly older.
Not Homer Simpson.
It's not Homer Simpson. It's Unicode.
Oh, darn.
Ugh. Okay, operators. So are you saying, I mean, wait a minute, and Jonathan had put a...
I have a better link now, so that if you, oh, sorry, not that. If you look at this Wikipedia page, every one of the symbols on this page has a Unicode version. There is a Unicode value.
That's not a lot of operators. That's not a lot of things.
Well, it is if you include the advanced ones.
Where are the advanced ones?
Advanced and rarely used symbols. So, you know, they have NAND, NOR, reversed turnstile, complements, unique existence.
I have a bad feeling that we invented that symbol for NAND. Or am I wrong? I think we did.
Is your hatred of the Sheffer stroke showing through?
Well, I think it should be dot in interesting cases. Yeah, the Sheffer stroke is really obscure. This is not a huge list, if I might say so.
Well, what mathematical logic symbols do you think are missing from this?
Well, mathematical logic as such, fine, but things that are formal, you know, formal versions of operators useful for mathematical theories represented in mathematical logic terms, plenty is missing. By the way, I do think the true and false symbols are useful here.
I agree.
And those just have, but you see, but look at this. This is, oh, I see. This is \top in, which one do we give? Do we give the 8868?
Oh, right.
\bracket 886, I mean, whatever it is. That is not what I thought it was going to be. Oh, we give the 22A4. Is that, what do we give? John,
you give the U+1, don't you?
John, what do we give him? \::? That hex?
The 4-digit hex.
Hex.
Yeah.
Okay. All right. So this is now, okay, whatever the thing is, let's see.
That's probably a T. I mean, if you unformat it, you'll see that it, well, it's not just that, right? If you just unformat it, you'll see it will have transformed itself to \bracket down T if you unformat that that input cell.
Okay. All right, fine. But that means that down T, now does down T have pausing rules?
Of course it does.
Yeah. I mean,
yeah. So that's the end of that as meaning tautology. Right. In fact, this is wrong. I mean, what they've done here, this is incorrect. I mean, this should be semantically tautology. But in fact, what they're doing is they're trying to hijack the down T symbol and claim that it's tautology, which is wrong. So I'm distinctly unconvinced by this list. Okay, so I think that makes the case.
Right, but if yeah, so here, actually, let me give you a better link. So this is the actual table of Unicode operators. So it's the table of contents, and then you'll find that there are various sections. There's mathematical operators, supplemental mathematical operators, and I think we've probably implemented a bunch of these, but
whereas
all of them.
Wait a minute, mathematical symbols. Okay. Letter-like symbols, mathematical operators. Okay, so supplemental operators. Yeah, I mean, I don't know how useful these are, because the problem is for mathematical representations of theories, we need multiple times-like operators. And having some bizarre creature that looks like this doesn't really help with that. I mean, we could arbitrarily start using bow ties, but that seems pretty random. Yeah, I mean, to me, I think we're going to have to draw some new glyphs, because I don't think these glyphs, these are not useful. I mean, these are fine and dandy, but they're not what we want to use.
Yeah, it's also not the complete list, but yes, I mean, we may or may
What's
not.
not the complete list of I mean, like the fact that they've got a double circled times there.
Well, this isn't the complete list of all the operators, right? This is one section. But
wait a minute, where do I go for the rest of them? I've got miscellaneous mathematical symbols.
Probably. At least I think there are more. I could be wrong, but
there's a large group of mathematical alphanumerics, but the sections we're looking in right now is where the majority of the operators are.
Right, but miscellaneous mathematical symbols does have a fair number of operators, like and with dot. So if you want and with dot, there's a Unicode point for that.
Okay, let me make a claim here, okay? I have a feeling that most of these Unicode characters had an intended use, and it's not our intended use. And therefore, we probably shouldn't use them for that, because eventually that might, I mean, who knows what one of these things is, but there may be some field in which that's a thing.
Well, I'm not suggesting using arbitrary things. I'm suggesting using things that look like the operators we want. Like there's an and with dot.
I understand that. But I think that we're going to have a whole family of things to which we give parsing rules. And what worries me is, like, for example, let's take this example of down T, okay?
Mm-hmm.
It probably seemed like the right thing at the time to make down T be an infix operator, okay? But the truth is that page claimed that down T is the true symbol, tautology, right? Which is that
I think that's just wrong.
Well, okay, fair enough. But I mean, that's the point. In the world of adopt a symbol, right? The question is, are these things, through and through meaning whatever they mean? Or are they, I mean, this is a very weird how to think about this. So the issue is, you've got these glyphs. I mean, it's like the fact that, okay, the question is, if there was a Chinese character that happened to look like a Z, would people entrain the ASCII Z to be that Chinese character? Answer, probably not. But I think there are places where, I mean, in a sense, that's what's happening. Okay, back in the day, when there used to be these ISO Latin 4 character set and so on, those kinds of things, there was another A in ISO Latin 4 that was different from the A that we use in ASCII. Does that make sense to people?
Yeah,
and they still exist in Unicode.
Yeah, and I mean, there's all kinds of things like this. There's the half-width katakana characters. There's Greek capitals that just happen to look very, very much like Roman capitals.
Right. I mean, look, it goes into, back when I used to use a typewriter, it didn't have a 1 key on it because you used a lowercase l to represent a 1, right? So, I mean, this has been going for a long time, but the question is, do we want to buy into that idea?
I had forgotten that, but I think that we had such a typewriter.
Yeah, well, that's the way they worked. Right, I don't think any typewriters had 1s on them. I think it was viewed as a superfluous glyph. Okay. In any case, my tendency is to say, unless the description here.
Right, I agree. The description, in order to reuse an existing code point, we have to have the description must match our intended use.
Okay. However, the problem is that, like the old, like typesetters back in the day when there were human typesetters with lead type and so on, right? They always had names for mathematical characters, and they were kind of humorously direct. Okay. There were things like fences, for example. Those are the absolute value signs. Were called fences. I don't remember any of the others, but they were kind of fun because they were really just purely, this is what it looks like. No reference to the meaning. And I think that's what Unicode, pretty much picked up, if I'm making sense, rather than so much giving meanings to these things. Because here we've got, left S-shaped bag delimiter. Okay, then we've got open subset. This is a mess, guys. This is a mess. I mean, oh boy. See, look at this. White triangle containing small white triangle. And then we've got three-dimensional angle. So three-dimensional angle is a semantic statement of what it's supposed to mean. And then some of these others, upper left corner with dot. It's just a structural description. That makes sense? I mean, look, left multi-map is totally different from left and right double turnstile. Turnstile, last I knew it, is not a mathematical concept. Is this making sense?
Right. Although there is a right. This is sort of the short form. There's usually more information somewhere about sort of the intended semantic meaning.
Well,
although right for a lot of these they're sort of random. Right, they don't have they're sort of random things that are used in different situations and for different things.
Right, but that's in the category of use the L key on the typewriter for a 1. Right. Mm-hmm. So the question is, so what Unicode I think has done is like the use the L key for a 1. It's like the glyph looks roughly right, use it for that. Right. So I mean, here it gives them, look, squared logical and says morphological min product operator, additive minimum operator. So these are possible meanings. That's the same thing we did in, who knows, maybe they got this for us. I don't remember. We were interacting with them a bunch in those days. Yeah, there are a number of interesting questions here on the live stream. Let me just look at some of these. There's Ethan is commenting that our symbols palette is utterly old and needs a search field in it, and I agree with that. And that should be listed as a project for somebody. Possibly that's a small NOAA project. Brady, that's for you to make a note of that.
Yes, got it.
But you could add that to user assistance. Okay. Then Nick is commenting there's a difference between arity 0 and no arity. Yes, you're absolutely right. I mean, arity 0 would be by nullery, I didn't mean, okay, so then there's, yes, I mean, how to say this. I mean, arity zero. What is the right term for this? Arity zero operators means something of the form f open close, whereas what is the right term for this thing where it isn't an operator at all? It is, that's the way that we are handling these formal, constants.
Right. Well, in logic, they're just called constants. But the point is, axiomatic theory treats them as though they're arity zero operators. Like if you call, axiomatic axioms operator arities, it will show the identity as being an arity zero operator.
Right. Okay. Emergence, ETS, I'm going to call them on our live stream, is asking, can you make custom symbols like draw an operator yourself? No, because we don't have a good way to define precedence. That was I've told this story 700 times. In SMP, we had a way for people to define operator precedences. What a disaster that was. I don't think we have.
Actually, you kind of can, because if you're willing to do work at the box level, because you can wrap your thing in a tag box and use a syntax form option to make it work like an existing operator. So if you're happy to have it be equivalent to an existing operator for purposes of associativity and precedence and such, then the answer is yes.
Isn't there a way of, there are precedence values, numerical precedence values. Can't you set those with precedence form?
Well, so, the thing is, you need something that works like an operator, and, the tag box with the syntax form option can encompass anything and make it work like an operator.
I see. It walks like a plus and it talks like a plus, but it doesn't look like a plus.
But syntax form is just limited in that you can't give syntax form a raw precedence and associativity and such. You have to specify it in terms of an existing operator.
Okay.
I actually posted an example of that in the chat right at the beginning before the conversation went someplace else.
And actually, precedence form is the opposite. It tells you for output formatting, parenthesize this thing as if it had this precedence.
So I began to understand that this example doesn't
represent
that this doesn't represent the direction we probably want to go, but maybe for the purpose of answering the question, you can see. So
what can I do here?
Well, so if you copy and paste these guys into like A formal plus B, formal times C, formal times D, and you'll see then the selection works equivalently.
But it doesn't parse.
You're going to have to write make expression rule for it. But if you triple click one of these things or something like that, it's mimicking the operator it's based on.
Right. What do we think?
And even so far as if you do formal star B, formal star C, you get something flat.
Right.
That, by the way, is why monospace fonts are awesome for coding.
What, you can tell the difference between those guys?
Yes.
Yeah, right. Because otherwise, I'm sure if we did text of that, yeah, that's pretty helpful. Okay, so backing up here, by the way, Hans asks, how much space is left in our created fonts to add our own glyphs?
Oh, lots.
And there's a lot of space in private Unicode.
Yeah, so, we still have a decent amount in plain zero of private Unicode, and soon we'll have full support of, beyond plain zero, and there's a ton of space.
And how bad is it when we use private Unicode?
It's not bad.
What do we do when we copy paste into some other application?
We use long names.
I see. So then what would happen is
we always convert anything, unless you're copying a bitmap of it, of course. But we'll always use a long name because we don't seriously expect anyone else to understand, our private Unicode. That's not a reasonable expectation.
So if I take this and I paste it into, a piece of email or something, I will get, oh boy. I get all kinds of. I see.
Well, I mean,
right, but if your recipient then takes, right, but if your recipient then takes this and pastes it back into their notebook, it'll regenerate.
But even if I just take that small piece, the AB piece there, that's still kind of, Oh, that's not too bad. That's
that'll be quite reasonable.
But it isn't. Okay, fine. So we've already crossed that bridge, basically. So anything we do in private Unicode space is not going to be any worse for this.
Right.
Okay. So I think the conclusion is, we should make our own glyphs, and that we should pick the precedences. That basically what we're going to do is, the same thing we've always done, which is just like in the main design of Wolfram language, we're picking functions that will seem useful. We're going to pick, glyphs and precedences and so on that will seem useful for purposes of for these formal theory purposes. So now that really just degenerates into, by the way, is there any problem technically with these nullary operators? They're just symbols, like they'll presumably be letter-like forms, just
exactly. Yes, the kernel and the front end will both just read them as letter-like forms, and that will not be an issue.
Okay.
Right. We'll just need to, when they're added, we'll just need to make sure they're created in system and protected so that they remain as true. Right.
Is there any problem? We've already got some ternary operators, right? Tilde is already a ternary operator, so we can presumably do the in the few cases like the between operator, which is ternary, we can deal with that, right?
So the you can potentially do quite exotic things with ternary, and you may not understand what's exotic from a parsing perspective. Yes, we have some basic ternary stuff, and it's we like the tilde example, the front end actually doesn't understand it properly as ternary, and we kind of hack around that and make expression. So A tilde B tilde C tilde D, the front end just considers that flat. Because the front end doesn't really understand ternariness.
Okay, all right.
Right.
Okay.
But make expression does.
Right, and so that will fail to parse unless you add some parentheses somewhere to tell make expression what you mean.
Okay, understand. So you're saying A tilde B tilde C tilde A tilde C will work just fine, but then this, if I add a tilde D, it'll okay. Well, that's fine.
But then tilde E will parse. But if you look at what the front end did, if you show
that is very bizarre that it parses with that right associativity.
Yeah, but the front end didn't do anything clever here. The front end just treated tilde as a flat operator and make expression figured out what you're looking at.
Okay, fine. All right, so look, I think this discussion has devolved into we need to actually do the mathematical. Okay, so now the only question is there a style that we want to get? I'm just going to comment on Sandra on the live stream comments that when you paste a Greek letter like eta, that pastes as / eta. The reason for that is that we're not using raw Greek characters. And in fact, I just got burnt with this because I was just doing something which you'll see in a couple of days about Euclid, where I'm quoting Euclid in Greek, and there are Greek characters that have accents on them, but we have automatically translated into our mathematical Greek font, which is italic, Maybe Andre wants to comment on this.
Actually, I have a comment about this, which is that right now we are using the Unicode code points for standard Greek letters, except for epsilon, which there was a mathematical epsilon that's in Unicode plain 0. But this is this is was probably the best decision in 1996. But there are better things we can do now, because we created kind of a mess for our Greek users, unfortunately, and we've tried various ways to make it better. But
wait. These are users who would otherwise have been using ISO Greek, the ISO Greek encoding before Unicode. So
yes,
correct.
Yes.
And they won't have had any problem with the ISO Greek encoding. But now that they're merged, it's a big mess.
So, there's a question of, well, do you want to use a Greek character from just whatever font you were using that's Greek? Or do you want our mathematical Greeks, which are, have a special sort of styling, which, as you say, for example, they have an italicized sort of appearance. That's part of our calling out, this is a mathematical thing. Well, since we first did this, there's a range of mathematical Greeks that's now come into existence, and it's on our roadmap to switch over our long names for alpha, beta, gamma, so on, to, instead of pointing to standard Greek, to point to these mathematical Greeks. And
that will be a compatible change, because our notebooks contain long names, right?
Exactly. Yes, we would. You could find sources of incompatibility, but 99% of what people ever do will just work, unless you're Greek. Unless you're Greek.
What's that?
So
that's Greek, right? That's
yes.
The Greek ISO Greek mapping.
Correct.
Yeah,
correct.
So that
and this would instead become I don't know the value, but it's not in plain 0. It would be 100,000 something.
Yowie.
Yeah.
Well, as incompatibilities go, that's probably not the most devastating one.
Conceivably, the Greek character you get when you're in text could be from a base font that is not ours, right?
Well, this is the dance that we do for our Greek users. We detect, is your preferred language, your preferred operating system language Greek? And if so, then we do different things for them. And I want to get to a world where we can stop doing that. Because for those of us who aren't Greek, it's like maybe we're quite happy as long as we don't have Greek friends. But but it is painful for our Greek users, and we need to deal with that.
Well, and to support it properly, we're talking about expanding our font to have a non-italic looking Greek characters, right?
No. I'm saying
we're just going to use the standard fonts, system fonts.
Yes.
Because the whole point is what John is saying is that there are now mathematical Greek characters in standard system fonts.
What we want is there isn't just one font for Greek, right? For narrative, modern Greek. There's a bunch of fonts, and people don't want to.
We're saying the font originally designed by Andre that is our mathematical font. Mm-hmm. We could still perfectly well use for the 100,000. Whatever.
Absolutely.
Unicode.
Absolutely. We just need to move some glyphs around. Change their mappings slightly, but
right.
That's a trivial thing.
Right. Okay. So just going back to this, let's see. I just want to talk about one last thing here. We're not going to get everything straightened out here, but I think we've got a roadmap which involves a much smaller number of people here. Which is, what is our style for a formal character? So we have chosen to use these dots for formal symbols, which I am not a huge fan of. If I wanted to make those formal symbols be a different color or a slightly different color, is that doable technically or not? As opposed to
the dot itself is gray.
It is. Yeah. The dot itself is not. It's not gray. It's slightly transparent. So the color follows the coloring of the.
So I mean, I guess this is in the land of
coloring.
emoji. We are the beneficiaries of emoji somehow here. A true statement that the characters can be. So what you're saying is, if we wanted to get rid of the dots and make these just a slightly different color, we could do that.
So, well, I mean, but
visually, I wouldn't recommend
that raises
that.
a question.
I like that the dots work. They're more noticeably meaningful. Changing color won't be as noticeably meaningful.
That's
and
okay.
we use so many colors already in our code. How could this work?
And the principal question is, what do you want font color to do on these things? Font color on a color emoji can't do a thing. So
I understand, but so you're saying here that dot, because it is purely opacity, if I say style of this, purple,
exactly,
this will. I see, beautiful. Right.
Yeah,
okay.
I like that.
Right, and I suppose if you made it pink, if you made it pink and added a black background, then the dot would be slightly darker than.
That's correct. That is absolutely correct. Yes.
Right. So in fact here I see what you're saying. So if I say white here and I say background arrow gray, this will, if I could only see it, be magnificent. Right. Good. Okay. So fine. So we're staying dotty. So the question is, what do we do with these operators? What is our style for a formal operator? Do we go dotty for that as well? Or do we have some other way of indicating that something is formal? And I need to go to another meeting in a second. That's my question.
I mean, I'm prepared to say dot, but I guess I could see if there's a dot under everything, maybe it becomes less clear. I don't know.
What would it look like? Let me see, because John has a dotting machine here, so we can probably.
Yeah, it's not perfect because it's not lined up correctly, but yeah, you get the idea though.
But what do you think graphically? If question Andre, Jeremy, etc. I mean, honestly, I don't think this would look so awful if everything was dotted here. It might even look better than only some things being dotted.
Well, I don't know. I mean, that was my point, that the some things being dotted make those some things stand out, and maybe that's useful. It's a visual interruption.
It's not particularly useful. It's interruptive.
Okay. But yeah, I lean towards sticking with this under dot approach. I was quite happy with it as we settled on it. Because remember, we used to do over and under, and that was too noisy.
Yes. But so maybe what we want to do here then is, I mean, and then what it'll look like if everything is underdotted is it'll almost look like a, partial underline type thing, which I think is sort of okay. And then my suggestion for the formal operators would be that we use times and plus as circles. We use a circled version. And then for the extra, we'd have a double circled version. And maybe what we call them is formal circle time. I don't know. Do we call them formal times? Formal? What do we call them? If we have two formal, if we call them formal circle plus, that's at least clear. But then we call it formal double circle plus or something. Jonathan or anybody else, you've got comments on this?
So the LaTeX convention is to have a letter and then variations of the letter are preceded by var. So like you have epsilon and you have var.
I know that.
Yeah, but I mean, it would be so what you just suggested, Stephen, is consistent with our naming conventions. That would be formal circle plus and formal double circle plus. I mean, just like we have double integral sign and.
Well, it's fine, but then. So it's a little bit verbose, if you have to type that in, it's pretty painfully verbose. And
right,
the question then,
But if you just need to do escape, DCF plus, or I guess F, or the dollar, whatever it is, right? So that's C plus instead of circle plus, right? So we'd need C plus, I guess dollar is what we are using of trailing dollar for formal variables, I think. I think escape A dollar, I think, is formal A. So I think we could just do that.
Yeah. So Bob is commenting on our listening. Bob had mentioned earlier something about, do we have vertex algebras, vertex operator algebras? I don't know what those are.
No.
What are they?
They're a type of operator algebra defined over the complexes that are useful in string theory and other sorts of algebraic geometry things.
Are they just a formal system, or do they have axioms?
Yes, although usually they, you think about sort of specific, concrete ones that arise in practice. Although I'm sure the mathematicians will treat them completely abstractly. In the physics world, you're more typically concerned with the concrete ones that appear in string theory.
So there is a fully axiomatized version of vertex operator algebras, but they require having concepts like vector spaces and linear multiplications and endomorphisms and things that we currently don't have.
Right.
In principle, it's perfectly possible to do.
Okay, so what we think we're doing here is most of we'll have a formal equal. I don't think we'll have a formal for all, because because for all is actually a meaningful concept in our logical theories.
We need to have a separate meeting about for all, because if we want to support higher order logic in the next version, we need to modify how for all works.
Okay, let's get that meeting.
And that'll obviously need to include people like Adam and Roger.
Can you say, Jonathan, what the change that you need is?
Yes. So if you try, if you say, for all f x y, and then you say, f of x y equals f of y x.
What the heck is that? For all f x, what the heck is that? I'm very confused. What I must have
that I think you attach some definition to for all that is triggering. Huh. Or for all is broken.
No, that's obviously correct because because
there's no
appearance of the x there. But I'm saying if you quantify over f, x, and y, and then you say f of x, y equals f of y x or something.
Well, but this thing here does not quantify over the f, and you're saying it needs to for second.
Right. So in order to support higher order logics, we need to be able to quantify over predicates. So right now, my higher order logic theorem prover gets around that by putting for all in hold form. But if this
doesn't look too horrifying, I don't see an obvious problem with this, except that clearly we can do things like saying things like, for all square root like this, which might get a little bit weird.
Right.
Boy, there's a question from Bob. Can variables be double formal? No, I don't think so. I think that this is a complicated mess, right? What is a variable is a very complicated story. This quickly segues into the general story of naming, which is one of the sort of banes of many, many things. All right, but I think the convention we're going to use then is that we are going to use pretty plain operators, but we're going to dot them. And that means that in our meeting to talk about operators, we basically are just going foraging in Unicode for operators. And they could be Unicode operators that mean anything. And we're just going to we're going to build our own glyph that basically has that form dotted, and we're going to call it formal, whatever we choose to call it.
So if we're going to use the standard, visuals that we have for dotting, that means then that the implementation is back in the front end camp. there won't be anything for Andre to do if all the symbols.
No, but we're going to have precedent. No, Andre won't have anything to do, but there will have to be precedents set up for all of them.
Oh no! I'm not saying that wouldn't be the case. I'm just saying that the rendering of the glyph will be composed by the front end as opposed to or synthesized by the front end as opposed.
All right.
To
So what you're going to need, basically, what it's probably going to be Mano who ends up actually delivering this stuff, is this table. There's presumably a version of this table that has actual precedence numbers in it. Is that correct?
We actually have a procedure for submitting characters, and it includes all the information that you need. And I can it's just a Twiki that people can drop stuff into.
Okay, fine. Okay, so can you provide that to
Jonathan? Sorry,
I guess to Jonathan and Jose.
Sure.
And Mano. Okay. Okay, fine. Then we'll need a separate meeting that is a glyph selection meeting. Go ahead.
Yeah, I just was speaking of character requests. Are you okay with APP as the input alias for application?
Do we have a glyph for application now?
We do not. And we don't have the character because we need all the information. So last time we were talking about using this half-filled circle.
Yeah, I wasn't completely sold on that. Yes, we were close on that. I think. Has anybody started designing that glyph? I mean,
no. And so I guess,
I personally would prefer AP than APP.
Okay.
I don't see any reason to have an extra character there. I don't think it does us any particular good. I mean, you could support both of them if you want to, but I would say AP is what we should have. And I think the half-filled circle is a little bit fussy. I mean, I'd like to see how it comes out. I mean, it could be that a circle just with a bit of weighting on one side will be okay. Or even just flattening on one side might be okay. What about a circle with flattening? I mean, I just think it's really, really fussy to have something that looks like, a moon phase character or something.
Yeah, but you're back to the situation we once had in the past where you recommended a dot being slightly ovoid, as if anybody could possibly tell the difference. It's just, I don't know. I think that minimal amount of distortion could be perceived as anti-aliasing failure, or something that just isn't obvious.
Okay, so this is a glyph design question. I mean, let's try some out. I mean, basically, what we've agreed is it's a circle with some kind of weighting on one side of it. How that weighting works is up to the glyph designer.
All right, I'll put that in the ticket, I guess, for Andy H. Andre.
Yeah, that's a good starting point. I mean, he'll run it by others of us, but yeah.
Okay. And we'll get that. But yes, so we should have the code point in the next few days, and then it'll just be waiting for a glyph.
Great.
Okay.
Excellent. Do we know the precedence? Did we figure that out? We did, didn't we?
Yes. I forget exactly where. I think we put it between at and.
Yeah, we figured this out.
Yes. Okay.
Okay. Sounds good. All right. Thanks, guys. Thanks for the comments on the live stream, too. All right. See you all soon.